Hello, and welcome back to Math 151. The topic of these videos is logarithmic differentiation, which is found in section 3.9 of the textbook. So far in chapter 3, we've developed lots of rules for differentiation, but there are still some functions that we don't know how to differentiate. For instance, what about the function f of x equals x to the x? So if you were to plug in 3, you'd get f of 3, that's 3 cubed is 27. Both the base and the exponent are changing here. This might remind you of the kind of functions that we differentiated using the power rule. The power rule said that if you have a function which looks like x to a number, then you just bring that power, that number, down and decrease it by 1 in the exponent. But the key thing about the power rule is that the power is not changing. It's a fixed number, that n here. But in our function, the power, the exponent, is changing. It's x. So it depends on the variable. That's no good. We also learned in section 3.9, the same section where logarithmic differentiation occurs, that if you have a function which looks like b to the x for a fixed base and a changing exponent, when you differentiate it, you get the natural log of the base and then b to the x. But here we're assuming that the base is a constant, is a specific number b. That doesn't fit our situation either, because here the base is changing. So what we need is a brand new idea. So here's the idea, and it's not something you could think of in 5 minutes. That's that you should take the natural log first. Take the natural log before you differentiate, and we'll see why that's helpful as we do it. So I want to take the natural log of f of x. That's the natural log of x to the x. And it's important that we simplify this using log rules. We have a log rule which tells us what to do when the thing inside the natural log is an exponent. When the thing inside has a base and an exponent, the exponent comes outside, and we just get natural log of the base. So here, for our function, ln of f is x times ln of f. Notice that I said take the natural log first. We're still going to differentiate. So first step was that we took the natural log, and now on the second step, we're going to differentiate. Here in 3.9, the same section, we learned that the derivative of the natural log function, ln of x, is 1 over x. That's going to be useful on both the left and right sides here. On the left side, we have ln composed with another function f. So the chain rule says to differentiate this whole thing here, the natural log of f of x, we have 1 over f of x times the derivative of f of x. That's what the chain rule tells us we have to do. On the right-hand side, we don't have a composition. We have a product, so we have to use the product rule. And the product rule says we differentiate this x and multiply it with the natural log, and we add another term where we leave the x alone and differentiate the natural log. So here we get ln of x plus 1. That's the derivative of x ln x. Now the important thing to notice is that what we wanted to find was this f prime of x. That was the goal. Always important to keep the goal in mind. And we almost have it on the left-hand side. The left-hand side is only different from f prime because it has this f in the bottom. But we know what f is. So what this equation is saying, if I multiply it by fx, it's saying f prime of x, that's ln x plus 1 times fx. But we know what fx is, so we get natural log of x plus 1 times x to the x. Okay, that's our answer. That's the thing we were looking for all along. So this idea, this weird idea of taking the natural logarithm worked. And we'll see as you go through the rest of these videos that that's not an accident. There's a whole big class of functions where taking the natural log and then differentiating makes your life a whole lot easier. And there's also a big class of functions, like this one, where doing this doesn't just make your life easier, but it's the only way we have to differentiate it. Please go on to the next video, where we'll talk about how to use this method in general.